Hi, in this video I'm going to do two examples for you to help you factor a trinomial with a coefficient other than 1. The method that I'm going to show you here is called split the middle term. Some instructors call it split the middle term, some instructors call it the AC method. Okay? What we're going to do on this trinomial, there is no GCF, greatest common factor, that I can pull out of all three terms. And the number in front, the leading coefficient, is something other than 1. So we're going to take this 6, we're going to multiply it by the 5. That's why some instructors call it an AC method, because A, B, and C from a standard form of a quadratic. So 6 times 5 is 30. I'm going to do that off to the side. I also now want to think about what numbers multiply to 30 that when I add them together are going to give me this middle term. So we need to think about, if I take this 6 times this 5, give me 30, what numbers are going to multiply to 30 that when I add them together I get 17, positive 17. If you think about the different factors, I came up with the numbers 2 and 15. They multiply to 30, but they add together to give me 17. So instead of writing my original problem with 3 terms, what I'm going to do is I'm going to split this middle term. I'm going to still have my 6x squared, but instead of saying 17x, I'm going to call it 15x plus 2x. Same thing as a 17, so I haven't affected my problem, but now I have 4 different terms. What I'm going to do here is I'm going to factor using what we call grouping. I'm going to group the first 2 terms and I'm going to group the second 2 terms together. Grouping these first 2 terms, I'm going to look for a GCF in this group. So I'm going to look for a number and a variable that I can take out of every term in this group. It looks like in this group I can take out a 3 and an x. When I take out a 3 and an x, that leaves me with a 2x plus 5. I'm also going to look for a GCF in this second group. So I need to think of a number or a variable I can take out of each term in that group. It looks like I can actually take out a 1 because there's no other common factor for those different terms, leaving me with a 2 plus 5. If you notice, now that I've factored, both terms have a 2x plus 5 in them, making them a greatest common factor between the 2 larger terms. So now I can factor out that greatest common factor, the 2x plus 5. If I take a 2x plus 5 out of this term, there's the 3x that's left. If I take the 2x plus 5 out of that term, I have the positive 1 left over. This is the factored version of 6x squared plus 17x plus 5. You can always double check by distributing or foiling it out. You should always end up getting what you started with. Okay? Here's another example. I have 3x squared minus 10x minus 8. I'm going to try splitting the middle term, or the AC method. I'm going to take that 3, I'm going to multiply it by the negative 8. That gives me a 24, or negative 24. I want to then figure out what numbers multiply to help me get that 24. But then when I add them together, I get negative 10. I noticed a negative 12 and a positive 2. Doesn't that multiply to give us negative 24, but add together to give me negative 10? So I'm going to use those 2 numbers to rewrite my original problem by splitting that middle term. I have the 3x squared, and instead of saying negative 10x, I'm going to call that a negative 12x plus a 2x. And then I have my minus 8 in the back. I now have 4 terms, and I can use the factoring method that we've learned called grouping. I'm going to group the first 2, I'm going to group the second 2, and I'm going to look for a GCF in each group. In this first group, it looks like I can take out a 3 and an x. When I take out that 3 and the x, I have an x minus 4 left over. You could always double check by quickly distributing through. 3x times x is my 3x squared. 3x times negative 4 does give me that negative 12x, so I know I factored that greatest common factor correctly. In the second group, it looks like I can take out a GCF, a greatest common factor, of a positive 2. If I take out positive 2, that leaves me with an x, be careful now, minus 4, right? Double check real quick. 2 times x is 2x. 2 times negative 4 gives me that negative 8, so I know that I did that correctly. What also helps is, look, now I have a new greatest common factor between my 2 larger terms. They both have an x minus 4 in them. So now I can factor out that x minus 4, that greatest common factor. When I take out the x minus 4, I have left a 3x in this first group and a positive 2 in that second term. So that means x minus 4 times 3x plus 2 is the factored version of that original. Try it. FOIL it out and make sure that you end up, after you combine like terms, getting your 3x squared minus 10x minus 8, splitting the middle term. I hope that helps.